Focusing on question 5, the algorithm below described as pseudocode estimates the value of a definite integral using the trapezium rule. The beauty of this is that you don't really need to know what the trapezium rule is. It's already given to you, you just need to know the context. That'll help you immensely. Consider the algorithm implemented with the following inputs, where trapezium, bracket, and then you've got ln x, 1, 3, and 10. The value of the invariable sum after one iteration of the while loop would be closest to what? So, it explicitly says after the while loop, okay? Which means, because when I look at this question, originally I would see the sum in the defined section. It says sum is f of a plus f of b. A lot of students will stop there, but the question explicitly asks for after one iteration of the while loop. So what we're looking for into the while, the second line of the while loop says sum is going to, and there's an arrow, we're going to define it as sum plus 2 times f of x. Okay, so essentially what's happening is that using the inputs we've got from the start of the question, f of x of course is the function to integrate, a is the lower end, and b is the right end. So what you're looking at is a function, I'm just going to draw it on here, but imagine that you've got your function, your lower terminal, your upper terminal, okay? And you've also got each width of those rectangles being h. Okay, that's what it's, so not h, sorry, n. The number of trapezium to use is how many there? N would be the number of trapeziums to use. Okay? We'd end up with the integral, and because we're substituting, we're inputting, sorry, ln of x is our function, we have our integral from 1 to 3, because the next two values are 1 and 3, of ln x dx, right? Where n is the number of trapeziums to use. To solve this, we're going to just go from top to bottom. We define our different variables. Our h value would equal to, and I'm going to write brackets, bracket 3 minus 1 divided by 10, which gives us 1 over 5. And I'm just using the h is equal to b minus a, so 3 minus 1, divided by n, which is 10 in this scenario, because we've inputted 10 in the question. From there, I know that the sum of the original one, not of the while loop, the sum would equal to, and it says f of a plus f of b, which of course is going to give us ln of 1 plus ln of 3, which inherently of course signifies the ln of 3. So now we know the sum is ln 3, and we know the h value is 1 over 5. I also know, because it says we're defining, again we're going top to bottom, x would equal to a plus h, a being 1 in this scenario and h being of course 1 over 5 as solved earlier, so it'll be 6 over 5. And I, there is no redefinition, it is I equals to 1. Now we move on to the while loop. Okay, the most important part is that we're looking for the sum. The first line which says I is less than n, so while I is less than n, do, etc., that's not particularly relevant in this case. It says after one iteration of the while loop, what is the sum? So we're just focusing on that sum line. It doesn't have I, it doesn't have n, let's just focus on that. So the sum after one iteration would equal to, and it says sum, or the original sum, which we said was ln 3, plus 2 times of f of x, which is ln of, and x, remembering, is 6 over 5, as we've defined that as 6 over 5, gives us an answer of approximately, when you put in the calculator, 1.4633. Therefore, the answer would be C. So really, we're looking from top to bottom. What are our inputs? What are our definitions? How do we redefine them? So as in when we substitute those values in, and then do our first iteration. Let's move on to question 7. Question 7, one way of implementing Newton's method using pseudocode, and it says here, and there's a key bit of information that a lot of students would miss, with a tolerance level of 0.001. Again, the context is more important than knowing how to do the actual question in this scenario. The pseudocode is incomplete, with 2 missing lines indicated by an empty box. Okay, so we've got the inputs, where f of x is a function of x, and x0 is an initial estimate of x-intercept. We know that. Which one of the following options would be most appropriate to fill the empty box? There's a couple of them that we know are incorrect off the bat. It says if, and then one of the x value, now it makes sense to say if our next x value minus our previous x value, what it's looking for is the difference between the two. Is less than 0.01, then return the previous x. So there's a couple of things wrong there. First thing is that the question says a tolerance level of 0.001, which means it's saying it could be plus or minus 0.001. It could be greater than, it could be less than, which means A, B, and C are all incorrect because they're explicitly saying the difference between the next value of x and the previous value of x must be positive 0.001, which is not a tolerance range of 0.001. So in that scenario, A, B, and C are all incorrect. We're focusing on D and E, where the only difference is return previous x or return next x. What it means by return is like the enter button on your calculator. Return means you're putting that value into the next line. The next line after our empty box is else, which means that the pseudocode is looking at this and saying, whatever number you give me, if it's not this, else we'll continue with this. So what we should be doing is understanding, well, we are trying to accept the next value of x unless it's outside of that parameter. In this box, we want that to be correct. Okay? So what we're looking at is the last option, where we have if negative 0.001 is less than next x value minus the previous x value, which is less than 0.001, then we return the next value of x. Okay? So we want to move on to the next one. Otherwise, we put in previous x as next x. Any questions? Okay.